wanted to tell the story about the article that I read. And the article that I read was an article about writing. The article was talking about how one of the biggest problems that you can do when you're writing is to be going in and fixing where you put your commas when you still haven't written the story yet. And that you need to get through and get the whole damn story on paper and get a nice big hunk of writing done before you go through and edit it and figure out where the commas go and change all the grammar and all that. And I thought about that in terms of game development. And I thought, this is actually something that we're very guilty of in game development a lot, of going in and sorting out the commas when we haven't written yet. Or in game development terms, going through and playing around with balance issues or messing around with a user interface or something like that when we still haven't made the game yet. And I think keeping yourself focused on making sure that each week you're concentrating on those tasks that are the tasks that are preventing your game from being playable, that's a very strong discipline to have as a game developer. I'm usually pretty good about it, but I think in Last Regiment I fell down a little bit, where we've been spending a lot of time with the UI and stuff like that because it looked ugly and we had conventions to go to and I couldn't bring something that brought ugly to these things. And I thought, what I really need to do is I need to step back a little bit and say, like, what's really missing from the game? What is it that we need to be doing that we haven't been doing? And the big things that came up is we have this big, huge promise that we've made to our fans that we're going to ship this game with an editor. And we have an editor. That's easy enough to do. I mean, we had to have an editor for us to build a game. But there's a lot that comes with having an editor and a lot of decisions that come with having an editor, like how do you upload maps? How do we decide which maps people see when they want to look through the uploaded maps? How do we get people to not spam their maps? How do we get people to make maps that don't suck? How do we get people to make maps that aren't garbage? How do we get people to make maps that don't look like penises? We had not really worked through a bunch of those issues, worked through what the user interface for a system like that would look like, what features are we going to need to make a system like that work. So I kind of put down my foot and said, it's time for us to go do that thinking. It's time for us to go do that design because we can't put that off any longer. The other thing that we have promised over and over again is we're going to make this game primarily a single player game. And I know that a lot of you guys are really into multiplayer and you're like, but I like multiplayer. And that's great. There will be multiplayer. We play it a lot in multiplayer. For me personally, I think multiplayer is one of the more fun things to do. But what we learned from Legends of Callasia was if you want to get a bulk number of users, a lot of those users don't want to play multiplayer because they don't want to be tied to having to play it right now. They want to be able to play in little chunks of time when they have free time. Somebody who may sometimes want to play multiplayer will also want to play single player a lot. And there are certainly people that just want to play single player. And if you don't have a good single player experience, you can't build the bulk of users that you need to make the multiplayer experience a good experience. And so we have to be a single player game. It's easy to say. Problem is, you can't just say, I'm going to make a single player game. You have to do the things that come with making a single player game. And they're not all as obvious as you might think. The first thing that people think is, oh, well, I guess you're going to have to write a story. That's part of it. That's certainly part of it. But there's a whole lot of other stuff that come with making a single player game. For instance, how do you make the game actually do stuff? How do you tell the AI, I want you to do this? How do you give missions to the player? How do you tell the player what he's going to do? What kind of missions is he going to get? How do you script those missions? What's the language that you script all of that in? And as you dig deeper and deeper and deeper, you come to this core question that there's this big, huge hunk of design that we haven't done yet, which is, how do I build missions? How do I build that single player game? And so I said, we got to put the brakes down and we got to go build that. And so I spent, and you were welcome to watch, for those of you who are here, you saw me actually sit down and build that scripting system, build the design for that scripting system, which I then handed over to Adrian, who is the coder on this project, and he is spending this week integrating that into our game and actually building that scripting system. But once that happens, that's only step one, right? And I know that everyone thinks, oh, well, step two is obviously the make the mission step. No. Actually, step two is the AI. If you make a single player game, you don't have another human there to make intelligent decisions. And people like to think that multiplayer games are harder to make because they think it's easy to imagine all of the issues in multiplayer. And there are, there's server issues and how does it work on the internet and all of that. It's easy to imagine that multiplayer is harder to make than single player. But in many ways, single player is much harder to make because multiplayer gives you this incredibly powerful tool which is another human being on the other end of this game thinking. In single player, we don't get that. Instead, we have algorithms that are supposed to predict behavior and come up with what looks like intelligent behavior. And the simpler the game, the simpler that AI tends to be. With games with very simple rule sets, Go, for instance, has an extremely simple rule set. There aren't many rules to know about Go. You can write an algorithm for a Go game largely based on it being able to predict forward X number of turns and brute force it, right? So it can say, oh, well, if you do this, then I could do this, but if you do this, then I can do this. And because Go has a very large map, I guess, so to speak, there are a lot of possible moves. And so for a computer to drive forward in a game like Go, that brute force approach can be very difficult. Chess, on the other hand, chess actually has a very limited rule set. I've got a knight, and there's really only 4 places that knight can go. I've only got so many pieces. It's very quick to do forward thinking in a game like chess. And over in chat, somebody mentions that they do have a computer program that can now beat humans in Go. This was actually a huge thing. This was a huge development because Go was a much harder game to forward project turns in. Chess was an easier game to forward project turns in. A game like Last Regiment, which has so many hexes and has so many units and so many different kinds of units and so many powers for units, when you start forward projecting out all of the possible things that could happen on any given turn, the brute force approach to AI of let's have this game think 4 turns ahead of you and think of all the possible occurrences, it's physically impossible. That we don't have enough computing power to do it. There's way too many hexes that everybody could move to. There's way too many powers that people could use. And also because some of the powers actually give a small amount of random generated damage, we also have to include what happens if this dies, what happens if this doesn't die, what happens if it takes this many hit points of damage or that. It's ugly. You can't do it like that. And so instead, what we have to do is we have to actually look at AI a different way. And the way that we look at the AI is, let us pretend that this computer is a human and let's give him some goals. Let's say you want to do this thing. And and because as a human, we can kind of figure out in this situation, a reasonable goal would be to do this. We might say, when you're being threatened by this unit, that would encourage you to defend this area. Or if you're attacking somebody and they're being very good at defending, this would be an encouragement for you to build a more aggressive unit, that sort of thing. And so we kind of come up with a series of goals for the AI to try to accomplish. And then we have to say, well, which goal is he trying to accomplish and why is he trying to accomplish that goal? So now we have to put together some tables and some charts. We start looking at threat levels. Does this guy feel threatened at this time? Why would he pull back his units and defend his base? Well, he would do that because the threat level around his base has risen, and now he's going to pull back his units and do something about that. This is not the best way to do AI. I mean, given a computer with limitless computing capacity, we could brute force it and we could just say, hey, try everything, see what works out best. But we can't do that. It's physically impossible with the computing power and the tools that we have right now. So we have to kind of go with in some ways a subpar method, but in some ways maybe a better method. It's funny when you think about a lot of games. I used to make first-person shooters, and if you want to make an AI for a first-person shooter, that's trivially easy. It's not easy, but in the world of AI, that's about the easiest AI there is to write. And the hard part of writing an AI for a first-person shooter actually is not making it good. I can make a first-person shooter that accurately gets headshots every time you have 1 pixel of your head showing around a corner. Computers can do that. They don't have any problem with that. They're doing that processing anyway, just to figure out what you can see and what you can't see. So to make a first-person shooter that has what you would consider a good AI, the problem is not making it successful. The problem is making it not successful. The problem is actually getting it to behave in a way that feels more human, to have it miss. How do we make it miss? How do we make it run to the wrong place or go somewhere else. There's a whole world of things that we have to dumb down the AI. But in a strategy game, it's the exact opposite. It's very difficult to make a strategy game AI that plays intelligently and can think about things and can do things. But if you're doing it from a brute force approach, the truth is all of your strategy game AI is going to end up playing very similar. This is why when you play chess against an AI, it'll ask you, do you want to play against a smart or dumb AI, but it won't ask you, do you want to play against an aggressive or a defensive AI. Chess AI doesn't work like that. Chess AI just basically says, what's the best move for me? And if essentially what's happening when you set it to a dumb AI is it's saying only look forward 4 moves. But if you're looking at a smart AI, look forward 20 moves, right? That's what you're actually getting with your smart sensing in chess. But in a strategy game, we can't do that. And so instead, what we end up having is something that feels more human. So we can actually make your AI seem cowardly, or we can make your AI seem really aggressive, or we can say this is an AI that tends to Zerg rush you right at the beginning, or this is an AI that tends to turtle. And we can program in those kind of behaviors. And so that's kind of how we end up having to do it. But here's the thing. All of this means we have to relate it to the powers and the abilities and the things that you have, and those things continue changing during the development of the game. So for me to put in a card that says this is the card that transforms you into a much more powerful unit, we have to tell the AI, well, when are you going to do that? When are you going to play that card? And we can hard code that. We can say, here's this card, and here's the specific code for this card that says, when you have this card, here's the rules by which you determine when you play it. But that means every time I change that card or I add a new card, I have to write a new rule set. This gets really, really tedious for the coders. And it also ends up with a lot of sort of weird results, because if you look at it from a mathematical perspective, you create permutations, right? So if I say this card has its own rule set, and I say this card has its own rule set, well, now I have to compare this rule set versus that rule set. Oh, now I have a third card. Well, that third card now needs to multiply its rule set by this rule set and this rule set. So that's 1 times 2. Now I have a third one. Now this one has to multiply its rule set by all 3 of these rule sets. And you get, in a mathematically, geometrically increasing number of possible permutations. Now there's another way to think about this. And the other way to think about this is how we'll probably be doing our AI, which is, instead of saying here are the direct rule sets for this card, we can say this card is this kind of card. So for instance, I may have a card which has a fire blast, and a card which shoots a musket, and a card which shoots artillery. Well, you know what? All of these are damage dealing cards. And so we can start looking at things in themes, and we can start saying, okay, this unit is here. And how does this unit feel right now? Does this unit feel threatened? Does this unit feel like, what is its goal? And so first we say, okay, your goal, for instance, might be to hunt down other units and kill them. That's a reasonable goal to give a unit. So we give it this unit's thought process is hunting, right? And so it goes out and it's hunting other units to kill. Oh, it's sighted another unit. What am I going to do about that? Well, let's compare its strength to my strength. If it's really strong and really powerful and I'm not, maybe it wants to run. Maybe if it knows that it's got a one of these spells that, or one of these powers that does damage at a distance, it would say, okay, I'm gonna use that and I'm gonna do damage to it. Maybe it knows enough to know that I can do damage at a distance, and I can look at that unit and see that that unit doesn't do damage at a distance. So I'm going to do damage at a distance, and then I'm going to retreat and wait for that power to power up again, and I'm going to keep doing that. And as long as it knows that that's a thing that it can do, any power that I give it, or anything like it that does damage at a distance, would fall underneath that sort of paradigm, and it would know how to do that thing. As you can see, this gets really heavy really fast, and there's a lot of stuff, and the more powers that you have and the more cards that you have and the more things that you can do, it gets heavy. And so when you start talking about making a game that has a strong single player component, this is what you're talking about. This is the work that you're talking about. It's not coming up with fun missions. It's not, I mean, that is part of the work, and there's certainly something that we'll be doing, but that's not the ugly part. Putting together this AI, making the game play intelligently is part of the problem. Now, we had this problem in Callasia. I mean, this is not new to us. This is something we've been through before. The Callasian AI was not terrible. It was not great, but it was not terrible. What we need to do is get better at this. But the other thing that we can do is we can cheat like we did in Callasia. And the question is, how do you cheat? Now, the way that players hate cheating is if I change the rule set, right? If I say they hit more often than I do, or they do more damage than I do, that kind of thing, people don't like that because they don't understand it. They say, well, I looked at the numbers and it looked like my guy was supposed to do this many points of damage and he didn't take that many points of damage, and that's because he's an AI. Fuck you, that's not right. And that's a fair criticism, and so we try to not cheat like that. But we can use the story to cheat, like we did in Callasia. So maybe he doesn't have enough gold to make enough units to fight you on a strictly 1-by-1 basis. You would tear him apart. But you know what? He's got a better tactical situation than you. He gets more reinforcements than you do. So every now and then we get a story pop up that says, you know, hey, so-and-so just got new armies or new reinforcements or blah-de-blah. And so they're playing against you at an advantage. Now, your advantage is, of course, you have your big, huge brain, and you can, you know, think faster than a computer can at these sort of things. Not faster, but you can think more strategically than a computer at these sort of things. And so you are using your big brain against its strategic advantage because it's getting more assets or more things. People tend to not mind that so much. They get that. A good example of that in a big game, for instance, is Hearthstone. If you play through the single-player missions of Hearthstone, they are scripted. There is, you know, they're very specific things that these special enemies can do that help them be a surviving unit. We'll be playing with stuff like that. We'll be playing with stuff like, okay, you know, they get reinforcements, or they get this, maybe they get a kind of unit that you don't have available to you until later in the game, that sort of thing. Those things, that's really the only way we can fight it. You know, I would love to say, well, what we'll do is we'll just make a smarter AI, and the AI will use the same units that you do and follow the exact same rules as you do, and it'll be challenging. That's a very hard promise to make. As a small indie studio, I don't have the huge room full of AI programmers that would be required to fulfill that promise. That's not something we can do. And if you want some proof to that, again, go play Hearthstone. Go look at how they do their single-player missions. And this is Blizzard. They have more money than God. And they have not managed to make the game interesting and fun against all of the options and all of the synergies and all of the things that you can put together in Hearthstone. There's no way that you're going to make an AI that's going to figure all of that out. It's almost impossible to do. And that's the reason Blizzard doesn't even bother. It's why they don't even try to do that. Instead, they make it play reasonably intelligently under a reasonable rule set, but give their AI some advantages. And as much as I know some people are like, oh, you know, I'm seeing it in chat right now. Some people are like, well, people didn't like the AI getting more reinforcements. Well, toughen up, Buttercup, because that's what you're going to get in this game, because there's really no other way for me to make this game challenging enough for you to play. Not with a complex rule set and all of the different cards and all of the different things that we have for the units to be able to do. You know, it's interesting. Some people are bringing up StarCraft as an example of, you know, look at how they managed to do that in StarCraft. Actually, if you look at StarCraft, it's a quite simple game in terms of what the AI knew or didn't know how to do. If you look at the options available to the AI in a game like StarCraft, essentially, that game you can build units. Those units can do missile damage or melee damage, and they do it over time, and they do it by running into somebody or running at a distance from somebody and doing it. That's a relatively straightforward thing to do. But even in that, even in StarCraft, that AI wasn't real hard to beat under fair rules. The only way that the AI could beat you was because it did those things faster. And this is part of the problem of being a turn-based game. One of the advantages that the AI has, or 12-year-old Korean kids on speed, is that they click really fast and they can make those decisions really fast. And so given me, and this is sort of similar to the FPS, right? I can make an AI in a real-time sim do everything that's available to it at exactly the second that it's available, right? The second that this thing can make a unit, it makes a unit. The second that this thing can build another building, it will build another building. I can create a rule set for it where it can just act faster than you can. It can click faster, it can think faster than you can. In a turn-based game, I don't have that advantage, right? I can't make the AI go faster than you in a turn-based game because you both have a turn to play. And for the game to be fun, we have to make sure that you have enough time during the turns that you have to play. So it's different. I know that the two seem very similar. I know that you think, oh, StarCraft is a sim game. I would say a better example, if you want to look at a game that can be that plays in a similar way to our game, would be to go look at Civilization. And Civilization, again, this is Sid Meier, this is Firaxis. These are some of the best game developers in the known world, and they're working on Civilization 6 now. This is something they've been doing for a very long time. So you're, again, best game developers in the world working on the 5th sequel of one of the largest licenses in the industry. They cheat. When you play Civilization at the higher levels, they cheat. The way they make it work is that it takes less time for their units to get built than yours do. They get to build stuff faster than you do. They cheat. That's how they get around it in a turn-based sim. Now, I'm not saying it's hopeless. I'm not saying there aren't things that we can do. And certainly hypermarking up the maps, giving certain areas on the map certain tactical advantages, and letting the AI know this is a part of the map that you ought to go to and do something with. There's a lot of things that we can do to make the AI seem smarter than it is. But I can tell you, fact up, again, in a turn-based simulation game that's reasonably similar to ours, the best game developers in the world, working on one of the biggest licenses in the world, still cheat. So it's an issue. But in any case, the reason I got on this topic, I didn't intend to talk that much about AI today. I'm sorry if it was boring to you guys. The reason I was bringing it up is this is a huge hunk of code that we haven't really done yet. If you play our game right now versus the AI is marginally intelligent, but you can pretty much stomp all over it. And so that's a huge thing that we have to do. And it's interesting. I think a lot of people, they look at a game like Last Regiment and they say, well, it looks like it's really coming along. You guys should be able to release this soon. It's not as far along as you might think, because there's these huge open holes in the game development that we are aware of. I mean, it's not something that's a mystery to us, but it's something that, looking at the game from an outsider, you might not know how much work there is left to be done there. And the answer is a ginormous amount. And one of the problems is that ginormous amount of work that needs to be done goes hand in hand with continuing to develop the rule set and new cards and new abilities and new changes to the rules. Every time I go in and rebalance things, that's going to change the rule sets around a little bit. And we have to make an AI that is adaptable to those various rule set changes.